Okay, in this lesson, we're going to be talking about quadratic functions. And a quadratic function, what we mean by that is any function of the form y equals ax squared plus bx plus c. Now, let me show you something. We've discussed linear functions in the past. Now, linear functions look like this. It's kind of like y equals mx plus b, to where x is to the first power. So that's linear. So what makes this quadratic would be this first term. As soon as you tack on ax squared, that x squared term creates a quadratic function. A quadratic function creates a U-shaped graph. So with linear functions, we had a line, but quadratic functions create this U-shaped graph called a parabola. Some examples. Using your graphing calculator, let's sketch the following functions. Let's see what would x squared plus 2x minus 5 look like. And I'm going to pause this and pull up some Desmos and show you. Okay, so here on Desmos are our two graphs that they ask us to graph. And you can see this U-shaped parabola, what we call a parabola. And then on the y equals negative x squared, let me take that one off and graph it. You see the exact same shape, except for this one's flipped over upside down. So my parabolas look somewhat like this. They just wanted to sketch it, didn't want it to be exact. And anytime you see that word sketch, that doesn't mean to draw an exact graph. That just means to kind of draw what it looks like. Now here's how you determine, notice the first was right side up. It would hold water if it rained. This one would shed water like an umbrella. So what makes it open up or down? And here it is. If A is a positive, now let's go back and talk about what A is. The number in front of x squared. If the number in front of x squared, which here is a 1, and here is a negative 1, is positive, then it will always open up. If A is a negative number, as in the second example, it will always open down. Parts of your parabola. A vertical line that divides the parabola into two equal parts is called an axis of symmetry. As we learned in elementary school about symmetrical or symmetry, all parabolas are symmetrical. And I know I did a poor job of drawing these, but the left side and the right side, if we go back to our graph here, it'll be perfect mirror images of each other. And you can see that with these two parabolas. And that symmetry is always evident. The line of symmetry that divides it into two equal parts is called the axis of symmetry. We have a formula for the axis of symmetry, which we are going to need to memorize. The formula for your axis of symmetry, notice it's x equals. X equals a number, if you don't remember, is always a vertical line. So since our axis of symmetry is a vertical line, it'll always be x equals. The formula is negative b divided by 2a. And we remember what a and b are from our standard form up here. A is the number in front of x squared, b is the number in front of x. So that's how we find our axis of symmetry. The turning point of the parabola. Like if you've got a parabola that comes down and then turns and goes back up. The turning point of our parabola is called the vertex. When the vertex is at the lowest point, because the vertex will always be at the lowest point, or if it's upside down, it'll be at the highest point. If the vertex is at the lowest point, it's the minimum because it's the smallest value. When it's at its highest point, we call it a maximum. So let's label these parts on the graph above. So we have our axis of symmetry, which I've already labeled here, axis of symmetry. We have our lowest point right here, which we call the vertex. Now, in this case, the vertex is the minimum. And here you see the axis of symmetry again. I'm just going to draw an arrow from over here. That's the axis of symmetry. This is the vertex. The axis of symmetry always passes through the vertex, very important. And with this vertex, since it is turned upside down, this vertex would represent the maximum. Okay, now, with the next few problems, let's identify some axis of symmetries and vertices or a vertex. It says determine whether each function has a maximum or minimum, then find the axis of symmetry and the vertex. Okay, here's how you do it. Y equals 4x squared, that's going to be turned up because if the number's in front of x squared is a positive, it's cupped up. So the vertex will be a minimum, the lowest point. To find the axis of symmetry, we're going to do x equals negative b divided by 2a. Now, this has no b. You notice that b is the number in front of the x, and there is no b here. So therefore, since there's no x term, there's no b term, then our b value will be 0. So you're going to do negative 0 divided by 2 times a is the number in front of x squared. And once you do all that, you get x is 0. So our axis of symmetry for this graph will be x equals 0. Okay, now let me remind you of something I told you a while ago. The axis of symmetry will always pass through the vertex. So if my axis of symmetry was x equals 0, then this vertex has to be located at 0 comma something. So all we've got to do to find the vertex, this 0 value will be the same. Then you simply plug it in to find your y value. So if f of x is equal to 4x squared, we're going to find f of 0 by doing 4 times 0 squared, and you'll get 0 for your f of 0 as well. And next one. Start out with your axis of symmetry. Well, let's start out with, first off, the negative x squared, which means it's going to be upside down. So my vertex will be a maximum point. To find the axis of symmetry, we're going to do negative b over 2a. Now, we have a b and an a here. The b value is the number in front of x squared, so that'd be a 6. Or excuse me, the b is the number in front of x. The a is the number in front of x squared, which is a negative 1. So we have negative 6 divided by 2 times negative 1, which is negative 2. So x equals 3 is your axis of symmetry. So your vertex is going to be 3, comma, and we simply plug in 3 into our original equation, and that's going to tell us the y value. So f of 3 will be negative, now this is important, make sure you put the 3 in parentheses, negative 3 squared plus 6 times 3. The reason I tell you that is you have to square before you negative. So this will be negative 9 plus 18, which is 9. So 3, 9 would be our vertex here. And you can always check this by going back and actually graphing it with Desmos. And here you see that graph, and here's what I've done as well. Your graph was negative x squared plus 6x, which I have graphed up here. And then I've done this as well. I graphed x equals 3, just to show you that that is our axis of symmetry. You see the symmetrical properties there. And you can come in here and click on that, and the vertex, that highest point, is definitely located at 3, 9. Next problem, number 3. Negative 2x squared would be an upside down parabola, so your vertex will be a maximum point. X is equal to negative b over 2a is how we're going to find our axis of symmetry. The b is the number in front of the x term. Again, y equals ax squared plus bx plus c. So whatever's in front of x is your b, and there is no x term here. It's missing. So your b value again would be 0. So you have negative 0 divided by 2 times a is negative 2. It doesn't matter about all this stuff because 0 divided by anything will be 0. So your axis of symmetry is going to be 0. To find your vertex, the x value will be the same. Now we're going to plug in 0 for x, and that's going to tell us our y value. Negative 2 times 0 squared plus 7. This will all be 0 plus 7 will be 7. Number 4. X squared, positive x squared. That means your vertex will be a minimum value. Your axis of symmetry will be located at negative b over 2a. So that'll be x equals. Your b value is negative 8, so you have negative 8 divided by 2 times your a value will be 1. Negative negative makes a positive. This will be 8 divided by 2, which is 4. So your axis of symmetry is located at x equals 4. That means your vertex will be 4, comma. Let's plug in 4. That'll be 4. I'm going to just go ahead and multiply it out as I plug it in. 4 times 4 would be 16. Negative 8 times 4 would be negative 32 plus 9. I like to add 16 and 9 first. It's 25 minus 32 gives me a negative 7. So 4 negative 7 will be your vertex. Okay, next up we're going to talk a little bit more about graphing these. And we're going to graph them without Desmos here. Here's a good way of graphing it. Remember with graphing absolute value functions, how we found the vertex first? And then we graphed on one side, and then we knew it would be mirror images for the other side. We can do the same thing here. So it says step number 1 to graph these things. Why not find the axis, symmetry, and vertex first? This is not a have to thing, but it helps a lot because once you find an axis of symmetry and a vertex, you can actually just graph one side and you already know what the other side is going to look like. It says place the vertex in as the middle row, just like we did with absolute value. Number up and number down to complete the table, and then we're going to graph it. So to graph this, let's find our axis of symmetry first. X equals negative b over 2a. The b term, b is what's in front of the, let me write it again up here, y equals ax squared plus bx plus c. The b term is the one, or the b number is the one in front of the x. Since the x term's missing, your b value is 0, so it doesn't matter what the bottom is because 0 divided by anything is going to be 0. So we're going to place that in our middle row. X equals 0. That's where our vertex is going to be located. To find the y value, again, you just have to go back and find f of 0. You just plug it back in. That'd be negative 3 times 0 to the second. That's 0, which is 0. So therefore, our vertex is located at 0, 0. So we can go ahead and plot that. Your axis of symmetry was also at x equals 0. So that's going to be this vertical line here that passes through the origin, that passes through your vertex. Now to find points on each side, just count up and count down. And you'll see that it's going to make it, again, so much easier to find this vertex first. To find these other points, we're going to plug in 1. Plug in 1 gives you negative 3 times 1 to the second power. That'll be negative 3. We're going to plug in 2, be negative 3 times 2 to the second. Make sure you follow order of operations. You got to square 2 first. That's 4. Negative 3 times 4 is negative 12. Square 3 first. 3 to the second is 9. Negative 3 times 9 is negative 27. We can plot these points. 1, negative 3. 2, negative 9. So that's going to be 2, negative 3, 4, 5, 6, 7, 8, 9 will be somewhere down in here. And obviously 3, negative 27 is not going to fit. Now, if we work this correctly, look what happens. When you plug in negative 1 and you square it, negative 1 times negative 1 is 1. Negative 3 times that would also be negative 3. You see you're getting the exact same values on this side, which should be the case because of the symmetry. So if 1, negative 3 is here, you've also got a point on the other side of the line of symmetry that matches it. And the same thing here, you have a point that matches this point on the other side of your line of symmetry. And here would be your parabola. Okay, domain and range. What can I plug into my shape? How far left, and that's domain. What are my x values? How far left and right does my graph go? The answer is, for all three of them, everywhere. Anything. From negative infinity to positive infinity, you can plug in any number you want. Your graph's going to go to the far left and to the far right. However, you don't have graph up here. So my graph starts at negative infinity. See, my graph continues beyond that, and it goes up, 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 up. So my range stops here. So my range will be all values from negative infinity up to 0. Now, is 0 included? Since it's a solid circle at 0, that means 0 will be included on my graph. Number 6. Always start out with your line axis of symmetry, negative b over 2a. Your b value here is negative 6, so you have negative negative 6 over 2 times your a value is 1. That'll be 6 over 2, which is 3. So your axis of symmetry is located at x equals 3. And you can draw that vertical line if you'd like. In order to find the y value of my axis of symmetry, or excuse me, of my vertex, you're going to find f of 3. You're just going to plug it in. 1 times 3 squared, that's 1 times 9, which is 9. Minus 6 times 3 is 18. I like to just do these individually, and then you have plus 11. Again, I like to do all the positives first. 9 and 11 is 20, and then when you subtract 18 from that, it gives you 2. So my vertex is located here at 3, 2. Notice your ax squared, your a term is positive, so that means your parabola should open upwards as we graph these. So I'm going to do one side, let's say 3, 2, 1, 0, 4, 5, and 6. Make sure you space it out the same so that your symmetry is evident. We're going to go through and one last time, I'll actually plug these in for you. On the next ones, I'll just pause the video and put the answers. When you plug in 2 to the second power will be a 4, minus 6 times 2 is 12, and then bring down plus 11. If you do the positives first, 4 plus 11 is 15, minus 12 is 3. So when you plug in 2, you get 3. When you plug in 1 to the second power would be 1. Negative 6 times 1 is a negative 6, plus 11. You do 1 and 11, you get 12, minus 6 is 6. And when I plug in 0, this is the best one to plug in. This is 0, and this is 11. So that obviously gives you 11. Now, if you plug in 4, 5, and 6, it should mirror those three values since you chose values that were equally spaced. So 3, 2 is my vertex, 2, 3. And I have a match on the other side of my axis of symmetry. 1, 6. And again, my axis of symmetry was here, so I've got another point on the other side. And then obviously 0, 11, and 6, 11 will not fit. So my parabola looks like this. There you go. Your domain for quadratic functions will always be negative to positive infinity because is there anything that I can't plug in for x? Can I plug in a million? Sure. So since you can plug anything in, your domain, your graph's going to go all the way to the left and all the way to the right forever. Your range, however, notice there's no graph. Your graph does not start until you hit your vertex. That y value is going to be 2. Then it goes forever. So 2 to infinity would be your range. Since 2 is your vertex, it is a dot on your graph, so let's include it. Number 7, we're going to graph these a little bit quicker. First step, find your axis of symmetry, negative b over 2a. Your b value is negative 8, so that's negative 8 over 2 times 2 on bottom. That's going to be 8 over 4, which is 2. Your axis of symmetry is located at x equals 2. And again, if you want to, you can actually draw a line there. To find the y value of my vertex, I'm going to plug that 2 in. And when I do, I get 8 minus 16 plus 6, which is a negative 2. So my vertex is located at 2, negative 2, which again, notice is on your axis of symmetry. Pick values on each side. You can do 3, 4, and 5. Notice I went up 1, so let's go down 1 for the other side, and we should see the symmetry. When I plug in 3, 4, 5, I get 0, 6, and 16. Now let me show you another pretty cool trick here. There's patterns. And this is only evident when you go up by the same amount. From negative 2 to 0, if you remember what we talked about with sequences, from negative 2 to 0, to get from negative 2 to 0, I'm adding 2. To get from 0 to 6, I add 6. To get from 6 to 16, I add 10. Do you see that pattern? From 2 to 6, that's up 4. From 6 to 10, that's up 4. And you should see that exact same pattern down here, and you'll have 0, 6, and 16 down here as well. Let's plot those points. And there's a picture of your parabola. Number 8, we always again start out with our axis of symmetry, negative b over 2a. Well, hang on, I did my domain and range over here. Domain again is negative to positive infinity. Your range starts here, there's nothing below it, and it goes up from there. So my range will be all values from negative 2 as my y value forever, including negative 2. Okay, now, negative b over 2a on this one. My b value is missing, so I'll have negative 0. It doesn't matter. 0 divided by anything will be 0. So if your b value is missing, it's always going to be 0 as your axis of symmetry. In order to find our vertex, again, we're going to plug that 0 in. You get 0 plus 5. That's pretty easy. So 0, 5 is going to be our vertex, which is right there. If done correctly, this is a negative x squared. This should be an upside down parabola. So let's pick values on each side, 1, 2, and 3, negative 1, negative 2, and negative 3. Plug those values in. And before I do need to remind you how to evaluate negative x squared. Make sure that you do not square the negative. When you take out the x, you're going to put the value that you're replacing it in parentheses. You're first going to square it, then you're going to put a negative in front of it. So I'll do one of them for you. We're doing negative x squared plus 5. So when I plug in 3, make sure you do 3 squared first, which is 9. Then you put a negative in front of it, so that's negative 9 plus 5, which is a negative 4. And this value down here should match it if done correctly. Now the other ones. And there's what I get. Now you can, again, check this by the patterns. You go down 1, you go down 3, and then you go down, I believe that would be 5, and you can see the pattern. You go down 2 extra each time, so that does check out. Let's plot these points and see what our graph looks like. And there's your graph. So your domain is what you can plug in, so negative infinity to positive infinity. There's no exclusions. Your range starts, again, where do you hit your graph? This graph extends down forever, and it stops here at that maximum value, and that maximum value was 5. So negative infinity up to 5. Number 9, your axis of symmetry, negative b over 2a. Your b value here is the number in front of the x, so that'd be 1, negative 1, so negative, negative 1 over your a value is negative 1/2, so we've got to do 2 times a negative 1/2. On top, negative, negative 1 is a positive 1. On bottom, a positive times a negative is a negative. 2 times a half is equal to 1, so you get negative 1. So negative 1 is my axis of symmetry. Now let's plug that value into our original to figure out what our vertex is. So you have f of negative 1. That'll be negative 1/2 times. We've got to do negative 1 squared, which is 1. Then you have negative, negative 1, which would be a plus 1. So we've got to do negative 1/2 times 1. That'll be negative 1/2 plus 1. Same thing as 1 take away a half would be 1/2. So my vertex is at negative 1, positive 1/2, which is located here. So go left 1 and then go up half a box. Now let's pick values on both sides. 0, 1, and 2. We can just go up 1 each time. But wait a minute, let's think about this. We've got to square the number, and then we've got to take half of it or multiply it by 1/2. So if you were to use only even numbers, it's going to make it a whole lot easier to plug in. So start thinking about your fractions before. Because when I square numbers like 1 and 3, I'm going to get odd numbers here. And I've got to take half of odd numbers, which is going to be decimals. So if we'll only use even numbers, it's going to make our graph a little bit nicer looking. So if I'm going to go up to 0, 2, and 4, let's say I went from negative 1 to 0. Let's go from negative 1 to negative 2 on the other side. And then I went up 2 each time, so let's go down by 2 on the other side by the same amount. Now let's plug those in. And there's what we get when we plug them in. Now you've got to be careful about something though. The pattern will not work because from negative 1 to 0 and from 0 to 2, that's not the same step. I went up 1, then I went up 2, and then when I went up 2 again. So don't focus on the pattern because that will mess you up on this because they're not equally spaced here, so that pattern's not going to work over here. Okay? When I plugged in 0, it gave me 0, so I can mirror that on the other side. When I plugged in 2, I got negative 1, 2, 3, 4. Or, well, I think I skipped. No, that's right. So let's mirror that. Let's see. 1, 2, that's 3 away from my line. 1, 2, 3 away from my line on this side. When I plugged in the third one, 4, I got negative 12. That's not going to fit. So connect our dots. And my parabola is a little bit wider. Now, why is my parabola a little bit wider on this? Because of the fraction out front. Anytime you put a fractional number out front, it's going to widen out your parabola. The bigger that number is out front, it's going to make it more narrow. So there is the graph of that. My domain is, again, anything I can plug in. My range, it starts at negative infinity because it goes down forever, and it stops at this y value, and you can always get that y value from your vertex, so it stops at a y value of 1/2. Okay, the next one, number 10. We have a piecewise function. So let's go ahead and our x equals -4. Let's go ahead and plot that division. Now on the left side of that line, we're just simply graphing a line. So we're at less than 4. We're going to graph the first part of our graph over here. Let's say 2x plus 5, so that's a y-intercept of 1, 2, 3, 4, 5. I'm doing an open circle because that's not part of my graph. I have a slope of 2, so I'm going to rise 2 and run 1, or down 2 and left 1. So my graph is going to look something like this. Now the question is, on the line, do I include the point? And I do not, because it's everything less than, so that's non-inclusive here. So I'm going to come down here and it starts here. So I'm going to do solid circles there, connect your dots, so my graph will look something like this, the first part. So I can erase all these other dots that were not part of my line. The second part, everywhere to the right of -4, over here, I'm going to graph this parabola. Now, first off, let's figure out what my axis of symmetry is. Same thing, negative b over 2a. So I've got, here's my b, and my a term's 1, so that'd be -3 over 2 times 1 is 2. So -3/2. That's a pretty ugly axis of symmetry. Now, that's -1.5. So I'm just going to sketch a little dotted line here just to show you that my axis of symmetry is going to be right there at -1.5. Now let's plug that in, as bad as we hate to, because of the fraction might not be as easy. Let's go ahead and plug that in and see what my actual vertex is. So plugging in -3/2. Let me clean this up a little bit. So we're going to square it. To square a fraction, well, first off, a negative times a negative is a positive. And to square a fraction, you can square the top and square the bottom is the easiest way. That'd be 9/4. Then we got to do plus 3 times -3/2. That'd be a positive times a negative, which is a negative. And 3 times 3/2, that'd be 3 over 1 times 3 over 2 would be a 9 over 2. We need common denominators, so let's multiply top and bottom by 2, and that would be 18 over 4. So 9 over 4 minus 18 over 4 would be -9/4. So probably the worst looking vertex that we've had thus far. So on our axis of symmetry, we got to go down 9/4, and if you need to, 4 going to 9 2 times. With 1 left over, that would be -2 1/4. So go -3 over 2, and then go down 1, 2, and 1/4. So just get it as close as you can. It'll be somewhere right in there. Okay, now we're going to go on each side of that vertex. Let me scoot that over just a little bit because it should be right in the middle there. So we're going to go to each side of that vertex, and we're going to pick some values to clean our graph up, to give us some more dots on our graph. So let's plug in maybe -1, 0, and 1. And what that's going to do, that'll give us enough values to where we can mirror those numbers on the other side of our axis of symmetry to give us some other values. So let's plug it in. And when you plug in -1, 0, and 1 into this, here's what you get. And let's go ahead and plot those. We have the point -1, -2, which is right here. Got stuff popping up everywhere. So mirror image across this line would be another dot here. When I plug in 0, I get 0, so that'd be a dot at 0, 0. Your axis of symmetry was here, so let's go the same distance on the other side. And then your last point was 1, 4. So go over 1, up 1, 2, 3, 4. Mirror to the other side of your axis of symmetry, which was here, and you're going to get a dot here. Now the question is, do you include the dot or you do not include the dot? And you do, because it's or equal to. So that should be plenty enough points to graph my parabola. It starts here, it goes down, it comes back up, and then it continues forever on this side. Notice I did not put an arrow on the other side because my line that divides it there didn't need me to. So I'm going to erase that line now, and I'm going to clean my graph up just a little bit. Okay, now domain and range. Is there any restrictions? I plugged in all values less than -4 and all values bigger than -4. That would be every value, including -4. Now, what did I get? My range. My graph starts at -infinity, and as I move up, I get an open dot here, and I get a little bit of a jump in my graph. I get an open dot at -3, so we're not going to include -3. Then I jump back up to my vertex. Now again, think about where your vertex was located. What is the y value on that vertex? Was right here. -9/4, which was also -2 1/4. Then my graph picks back up, and even though it stops here on that side, it continues up forever on the other side all the way to infinity. Now make sure, and I did mess up here, since your vertex is a point on the graph, make sure that you do include -2 1/4.